Welcome back to What Is, the show where we take the universe's most complicated concepts and try to explain them before your coffee gets cold. Today, we're tackling a heavy subject. Literally, we're asking, what is gravity? Now, you probably think you understand gravity. It's the reason your toast always lands butter side down. It's the reason you can't dunk like LeBron James. It's the reason the Earth doesn't just wander off into the dark, cold void of the cosmos because it's bothered. But if you really stop to think about it, what is it? Is it a ghost? A magnet? Is the Earth just really needy? In the simplest terms, gravity is an invisible force that pulls objects toward each other. Anything that has mass, meaning any physical stuff, has a gravitational pull. You have mass, therefore, you have gravity. You are technically, at this very moment, gravitationally attracting the person sitting next to you, or your cat, or that half-eaten burrito on your desk. The reason you don't feel it is because your mass is, frankly, pathetic compared to a planet. To get a real pull, you need a lot of stuff shoved into one place. For a long time, humans were pretty clueless about this. Aristotle, a very smart guy who was wrong about almost everything in physics, thought things fell because they were trying to reach their natural place. He thought a rock fell because it was earthy and wanted to be with the ground, and smoke rose because it was airy and wanted to stay high. It was very poetic, very philosophical, and completely incorrect. Then came the 1600s and a guy named Isaac Newton. You've heard the story. An apple falls on his head. He has a eureka moment, and calculus is born, to the eternal misery of high school students everywhere. Whether the apple actually hit him is up for debate, but Newton's realization was world-changing. He realized that the same force pulling the apple to the ground was the force keeping the moon in orbit around the Earth. He called it universal gravitation. Newton's math was brilliant. He figured out that the strength of gravity depends on two things: mass and distance. First, mass. The more stuff an object has, the stronger its pull. That's why the Earth keeps us pinned to the ground. But you don't find yourself accidentally orbiting your refrigerator. The Earth is massive. The fridge is just full of condiments. Second, distance. The further away you get from an object, the weaker its gravitational tug becomes. This is why astronauts feel weightless. They aren't actually outside of Earth's gravity. They are just far enough away and moving fast enough sideways that they are essentially in a constant state of freefall. But Newton had a problem. He could describe what gravity did, but he couldn't explain how it worked. He basically said, look, I have the math, but I have no idea how the Earth reaches across 93 million miles of empty space to grab the sun. He called it action at a distance, which is scientific shorthand for its magic. Don't ask me. It took another 250 years for a guy with even wilder hair to solve the mystery. Enter Albert Einstein. In 1915, Einstein published his theory of general relativity, and it flipped the script. Einstein said gravity isn't a pulling force at all. Instead, he imagined space and time not as an empty void, but as a fabric, the spacetime fabric. Imagine a trampoline. If you place a bowling ball in the center of that trampoline, it's going to create a dip, a curve in the fabric. Now, if you take a marble and roll it across the trampoline, it's not going to roll in a straight line. It's going to roll toward the bowling ball, following the curve. According to Einstein, that's exactly what gravity is. The sun is a massive bowling ball, warping the fabric of the universe. The Earth isn't being pulled by an invisible string. It's just rolling along the curve created by the sun's mass. This was a mind-blowing revelation. It meant that gravity isn't just something that affects stuff. It affects light, and it even affects time. If you're near a very strong gravitational source, like a black hole, time actually moves slower for you than it does for someone back on Earth. This isn't just science fiction movie logic. We actually have to account for this with our GPS satellites. Because they are further away from Earth's mass, their clocks tick slightly faster than the clocks on your phone. If we didn't use Einstein's math to correct for gravity's effect on time, your Uber would end up 3 miles inside a lake. So, gravity is the curvature of spacetime. But what happens when gravity goes into overdrive? When you get too much mass in too small of a space, you get a black hole. This is a place where the warp in the fabric of the universe becomes so steep and so deep that not even light, the fastest thing in existence, can climb out. If you fell into one, gravity would be so much stronger at your feet than at your head that you would be stretched out like a piece of spaghetti. Scientists actually call this spaghettification. It sounds delicious, but it is fatal. On the flip side, what if gravity just stopped? If gravity took a lunch break right now, the atmosphere would immediately drift off into space. The oceans would float away. The Earth itself, which is held together by its own gravity, would likely break apart as it continues to spin at 1,000 miles per hour. You wouldn't just float. You would be launched into the vacuum of space along with your house, your car, and that burrito we mentioned earlier. Gravity is the ultimate silent partner. It is the weakest of the 4 fundamental forces of nature, literally. A tiny refrigerator magnet is strong enough to defy the entire Earth's gravity to pick up a paperclip, yet it is the one that shapes the entire cosmos. It builds stars, it herds galaxies, and it keeps your feet firmly planted on the sidewalk. We're still learning about it, too. We've recently discovered gravitational waves, literally ripples in the fabric of space-time caused by massive collisions in deep space. It's like hearing the universe ring like a giant bell. So, the next time you drop your phone and the screen cracks, don't be too mad at the floor. Be amazed that you are living on a giant rock that is currently warping the very geometry of the universe, just to keep you from floating away into the dark. Thanks for watching this episode of What Is. If you found this explanation uplifting, or if it just weighed heavily on your mind, make sure to hit that like button. Don't forget to subscribe and ring the bell so you never miss a dive into the mysteries of our universe. What do you want us to explain next? Dark matter, the speed of light. Why your headphones always get tangled in your pocket? Let us know in the comments below. Stay curious, and we'll see you in the next one.